My first math problem, I'm going to use an addition. Now, like most fraction problems, or in all fraction problems with this, we have to match the denominators, so that way we can have an easy and forward outcome. Now, rule of thumb is with a variable plus itself and a variable plus the same number, we'll have an outcome with the variable squared minus the numbers squared. And we see that here with n squared minus 9 from n plus 3 and n minus 9. Therefore, we already know our denominator, our matching denominator, which would be the lowest common denominator, or how they would refer to, would be n squared minus 9. So, what we're going to do is we're going to keep 5 over n squared minus 9 the same, and the two variables, or the two fractions that we're going to be using with, is 1 over n plus 3 and 2 over n minus 3. Now, when multiplying these together to keep the same outcome, we also have to work with the numerator. So n plus 3 will be multiplied with 2 and the bottom n minus 3, and vice versa with n minus 3 and 1 and n plus 3. So since they'll be sharing the same denominator, there's no need to put it on the bottom, but at the end of this, you would get n minus 3, because times 1 it would be the same, and then 2 times n plus 3. Now, putting this together, you would get n minus 3 as an individual, because when things are in pairs and like this, you keep them in the same area, plus 5 equals 2 n plus 3. And now with this, honestly, you can simplify it. So this would be 2n plus 6 equals 5 minus 3 and n. Simplifying this, you would get 2 plus n equals 2n plus 6 minus the 2, and then minus the other 2. You would get negative n equals 4. So n would equal negative 4 over n squared minus 9. That would be your answer. So for my next problem, I'm going to be using dividing. So to begin with, we are not going to solve with an outcome expression, so in that we're just going to solve for the variable still, but with not an outcome yet. So the question is 5p over p plus 7 divided by 5p over 3p plus 21. So with this, we do not have to share a common denominator at the end like it is with plus or minus. With that is, you're just going to multiply the denominator over the other denominator and solve with that, and still simplify. Now it's also just like with multiplication, only with a few extra steps. And what I mean by that is that you keep the regular fraction, you keep the original fraction that you're dividing everything over, so 5p over p plus 7, and then you switch the dividing into a multiple, so you're multiplying now, using the same steps there, but with the twist of flipping over the denominator and the numerator for the last problem. And in this case, it's now 3p plus 21 over 5p. Now with this, you're going to multiply the tops with the tops and the bottoms with the bottoms, and you would get 5p times p plus 7, and 5p with 3p plus 21. Now with this, you want to simplify 3p plus 21 so you can get a better answer with it with factoring, and what you would get out of that would be 3 times p plus 7. Now what you notice is that with this new expression that we have, which would be 5p times 3 times p plus 7, also has two of the same multiples on the bottom, and that would be 5p and p plus 7. So with that, you can cancel those out, and doing so all you'll have left is a 3 on the numerator. Now, you would think that that would mean that there is no rational expression, but on the bottom, there's always a technical 1, an invisible 1 that's always in its nature. That's the nature of math. So it would be 3 over 1. Therefore, your answer would be 3.